This is the first section of chapter 5 in a further FP1 book, the t-formula. Now, the t-formula itself is just this: t equals the tan of theta over 2. And the reason why we use t in the place of tan theta over 2 is because it allows the simplification of solving trig equations. So we'll need to be able to solve trig equations. It allows us to prove identities. So it just allows the simplification of proving identities, and also the simplifying of expressions. And actually, when you do algebra, when you do trigonometry, these are the three main things you're going to be doing: solving trig equations, proving identities, or simplifying expressions. Now, this is an AS topic, but there are some things you need to know from the second year of Pure 2. Now, I'll put links in the bottom in the description for what you'll need from Pure 2 if you haven't done Pure 2 yet. Some of you may be doing your A-level maths in year 1 and then further maths in year 2, in which case you'll know about this. If not, if you're doing further maths and normal maths side by side, so there's some things you'll need to know about. So the first one is the double angle formula, and there's a double angle formula for sine, cos and tan. So let's start with the one for sine. So sine 2 theta equals 2 sine theta cos theta. I'm not going to go through these in this video. You can watch the other video that I have on Pure 2. Look for the link for it in the description and you can watch it there. I'll make these into boxes here so that you know they're not minus signs. We have a double angle formula for a cosine, which is cos 2 theta. Now this comes in three forms. We can either have it as cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. There's also a double angle for tan. This one gets used less often. You're more likely to be using the sine or the cosine one. And this one is 2 tan theta over 1 minus tan squared theta. So they're the double angle formulae. You'll also need to know about the reciprocal trig functions. So you'll need to know about secant, which we abbreviate to sec theta, and the definition of that is that it's 1 over cos theta. You'll also need to know about cosecant, which we abbreviate to cosec. Let's just do this a bit further down. So cosecant theta, which, as I said, we abbreviate to cosec, and the definition of that is 1 over sine theta. And then we have cotangent, which we abbreviate to cot, and that definition is 1 over tan theta. Okay, so this is, I'll put this just over here. This is what you'll need from Pure 2. So let's go back to this t formula here. T equals tan theta over 2. And let's see what we can do with this. So let's just take these out here, create a bit of space, because we're going to see if there are other things that we can prove just using that. So I'm basically just going to start with a right angle triangle like this. And if I call this angle here theta over 2, and tan is opposite over adjacent, so this side would have to be t, this side would have to be 1, so t over 1 is t, and the hypotenuse is going to be the square root of t squared plus 1 squared. I'll do it as 1 squared plus t squared. Okay, so I'm going to start with that. Now from that, I can actually write down that sine theta over 2, using that right angle triangle I've got there, that's going to be the opposite over the hypotenuse, so that'll be t over root 1 plus t squared. I can also do the same for cos theta over 2, not cos theta over 2, that's going to be the adjacent over the hypotenuse. Okay, so this is just using Pythagoras. So square root 1 plus t squared. Now from here, I'm going to use a double angle formula because what I really want is an expression for sine theta and cos theta. So if I start with sine and I use the double angle for sine, then sine theta is going to equal to 2 sine theta over 2 cos theta over 2. Yeah, double theta over 2 is theta. So let's work out what that is. So that will be 2 lots of sine theta over 2, which is t over root 1 plus t squared, times by cos theta over 2, which is 1 over root 1 plus t squared. Now if we simplify that, what we'll get is 2t over 1 plus t squared, because you're going to do the square root times the square root. So now we have an expression for sine theta. We can say sine theta is 2t, if we use the t formula, 2t 1 plus t squared. Now this isn't in a formula book, so this is something that needs to be learnt and memorized, because we're going to be using this a lot in this chapter. Okay, now let's do the same thing with cos and use the double angle for cos. So with the cos, the double angle that we're going to use, or we could use anyone really, so we'll use cos theta is equivalent to, let's do the 2 cos squared theta minus 1. So 2 cos squared theta minus 1. So that's going to be 2 times, oh sorry, that's theta over 2. My bad, it's a double angle. So 2 times, so we replace cos theta with 1 over square root 1 plus t squared. And that's going to be squared. And then we minus 1. Now, since I probably want to put this all together, I'm going to write 1 as 1 plus t squared over 1 plus t squared. Because when I square this out, I'm going to get 1 plus t squared in the denominator, and that will allow me quickly to put them together. So I will end up with 2 over 1 plus t squared. Once that gets squared and you times it by 2, take away 1 plus t squared over 1 plus t squared. And that will leave me with, so you've got 2 minus 1, so that's going to be 1. So 1 plus t squared, sorry, 1 minus t squared, because I'm going to be subtracting both of those. Maybe I should have put it in brackets. So 2 minus 1 is 1, and then nothing minus t squared is going to be minus t squared, not plus t squared. And then 1 plus t squared. Okay, so now we have an expression for cos theta. Let's put this over here. So cos theta is 1 minus t squared over 1 plus t squared. So again, this isn't in the formula book, so this result needs to be memorized. Now, since tan is sine over cos, we can get a similar result for tan theta just by taking the result we've got for sine and dividing it by the result we get for cos. And if we do that, we will just end up with 2t over 1 minus t squared. Again, another result that needs to be learnt. Okay, so everything that's in the red boxes here are the things that we need to memorize. Let's highlight them as well. Now, we could use the reciprocal functions. So, for example, I could say that cosec theta, which is the reciprocal of sine, is 1 plus t squared over 2t, or sec theta is 1 plus t squared over 1 minus t squared. You just flip them over. And cot theta would be 1 minus t squared over 2t. In the same way, you could say that cot theta over 2 is 1 over t. So with these, there's lots we can do, and we're often going to be getting questions, writing them in terms of t, simplifying what we have in t, then referring back and maybe saying, okay, the result I've got looks like one of these. Yeah, along with maybe using some double angle formulae, maybe in part of our work, or these reciprocal trig functions here. Okay, given that tan theta over 2 equals 3/4, find the exact values of sine theta and cos theta. Okay, so you'll recognize this is like the t equals tan theta over 2. So in this question, t equals 3/4. So that'll be the first thing we write down because that's given. So in part A, where we need to work out sine, we need to remember our definition for sine in terms of t, which is sine theta is going to be 2t over 1 plus t squared. And then we just substitute the numbers in. So now that's going to be 2 times by 3/4 over 1 plus 3/4 squared. So that will give you 6 over 4 divided by 1 plus 3/4 squared is going to be 9 over 16. Using our calculator to work that out. And we get 24 over 25. And part B, where we have cos theta. So again, we need to remember our definition for cos theta, and that's 1 minus t squared over 1 plus t squared. And again, we just substitute t for 3/4. So it's going to be 1 minus 3/4 squared over 1 plus 3/4 squared. And again, if we use our calculator to work that out, that will give us 7 over 25. Now, I suppose you could work this out by drawing a right angle triangle like this, calling this angle here theta over 2, and saying, right, the opposite over the adjacent, well, that's going to be 3 over 4, so that means that this side is 5, and then get a value for sine theta over 2, which would be 3 over 5, and cos theta over 2, and say, well, that's 4 over 5, and then use the double angles from there. But it's quicker to use the t-formula to do that. It's much quicker than like trying to do these out. And what you definitely wouldn't do is like tan inverse of 3/4 and then double it and try and work it out that way. Yeah, because you may not get an exact answer if you do that. The T formula is the way to go. Yeah, it's going to be much quicker. Okay, so in this question it says, given that our angle theta over 2 is between pi and pi over 2, and that sine pi over 2 is 8 over 17, first bit we need to do is to find the value of cot theta. Now we could just dive in and do this question, but let's think about what steps we're going to take to answer this question. So I would say that the first thing we're going to do, if we've got sine theta over 2, we're going to find cos theta over 2. And we can do that by using sine squared plus cos squared. Once we've got cos theta over 2, we can do sine over cos to get tan. And that'll be tan theta over 2, which is t. Then from there we can use the t formula to get tan theta. And then from there we can just do the reciprocal to get cot theta. Yeah, so they're the steps we're going to take. So it's worth thinking about what steps you're going to do before you start the question. Now, we need to look at what it says about these angles. It says theta over 2 needs to be between pi over 2 and pi. So if I draw a cast diagram like this, so 0, pi over 2, pi, 3 pi over 2, it's telling me that theta over 2 is going to be in this area here. Now what does that mean? That means that when I work out cos, it's going to be negative. Sine will be positive, and it's positive in the question. And tan, well, that will also be negative. Okay, so now we're ready to start. So let's find cos theta over 2. So we can say since sine squared theta over 2 plus cos squared theta over 2 is equivalent to 1. So from there, what we can say is that, well, if we rearrange it, sine squared theta over 2 or cos squared theta over 2 is 1 minus sine squared theta over 2. So let's start put some numbers in now, and then we'll square root it afterwards. So cos squared theta over 2 is 1 minus, now sine squared theta over 2 is going to be 8 over 17 squared. Okay, so cos theta over 2 is going to be the square root of that. So I'll work that out. So I'm just typing a fraction, 8 over 17, or 8 squared over 17 squared. And we're going to do 1 minus that. Okay, so I get 2, 5 over 2, 8, 9. I'm going to square root that. And I get 15 over 17. Now, what did we say from before? That cos is negative. So we need to put a minus sign here. And I suppose, you know, when we square rooted to get that, it could have been plus or minus, but the cast diagram tells us it's got to be minus, it's got to be negative. Okay, so now we've got theta over 2. What was our next step? To find tan theta over 2. So tan theta over 2 is going to be equal to cos theta over 2, which is 8 over 17. So 8 over 17 divided by cos theta over 2, which is negative 15 over 17. So we'll work this out and see what we get for that. So 8 over 17 divided by negative 15 over 17, and we get negative 8 over 15. So minus 8 over 15. Now tan theta over 2 is t. So t equals negative 8 over 15. And we expected it to be negative because what did we say from our cast diagram up here? That tan would be negative. Right, so this is an important step now. We've got our value of t. Now we go with our definition of tan theta. So we will need to know what our formula for tan theta is. So that's 2t over 1 minus t squared. Okay, so that means that tan theta is equal to 2 times negative 8 over 15 over 1 minus negative 8 over 15 squared. So I'll work that out for my tan theta and see what I get. And that gives me minus 240 over 161. So just the reciprocal of that for cot theta. So that'll be negative 161 over 240. So there we go. So worth thinking about the steps you're going to follow before you dive into the question. Yeah, because we need to know what we're working out, and why we're working it out. So we really want to get to that tan theta over 2 at some point and then work our way from there. Okay, part B. Find the value of sec theta plus cosec theta correct to 3 significant figures. Okay, so if you're not familiar with sec theta and cosec theta, you can refer to the first slide or look in the description at the bottom and the links to Pure 2 where you can learn about them. But sec theta is 1 over cos theta and cosec theta is 1 over sine theta. So we can use the t-formulae, but obviously they're going to be the reciprocals of them. So since cos theta is 1 minus t squared over 1 plus t squared, we do the reciprocal of that. So we'll have 1 plus t squared, you just flip it over 1 minus t squared, and then plus, and then the reciprocal of the sine theta t-formula, which is 2 over 1 plus t squared. You flip it over, you'll have 1 plus t squared at the top over 2t. Okay, now the rest is just putting in our value of t of negative 8 over 15. So it will be 1 plus negative 8 over 15 squared over 1 minus negative 8 over 15 squared plus, and then it's going to be the same up here, 1 plus negative 8 over 15 squared, then at the bottom 2 times by negative 8 over 15. Now you can do this on your calculator, but you may find it just as quick working this out manually. But since we're going to be given an answer to 3 significant figures, we might as well just work it out on our calculator. Right, so having typed all of that in, I get 0.590864 and so on. And it needs to be to 3 significant figures. So 0.591. So there we go. That will be our answer for that bit there. Okay, should now be able to do exercise 9A on pages 119 to 120. Just a quick recap now of your t-formulae. So the big one that we sort of start with is this tan is theta over 2. Let me do this differently. Let's do this as like a little spider diagram, because this is t equals tan theta over 2 is like the glue that holds all of this together. So what can we get from that? Well, we can get sine t or sine theta is 2t over 1 plus t squared. Then cos theta, it'll be 1 minus t squared over 1 plus t squared. Tan theta, which will be like cos over sine, which will give you 2t minus 1 minus t squared. And then we can get our reciprocals from these as well. So we can get cosec theta, that's going to be 1 plus t squared over 2t, reciprocal of sine. Then we can have the reciprocal of tan, which is cot theta. So that's going to be 1 minus t squared over 2t. And then lastly, we can have the reciprocal of cos, which is sec theta. And that's going to be 1 plus t squared over 1 minus t squared. And the ones which you need to learn, well, obviously this one, the sine, cos, and the tan. Once you know those, then the reciprocals basically fall into place after that.